Go Chelsea or to Wednesday.
My mom didn't want me to come, didn't want me to come to school today because she thought I was still gonna be really sick.
There you
Well,
go. In case you want.
that's fine, just do like Graham and take the morning off and make it by third block, that'd be cool. He got out of bed just for us, that's good. All right, fourth blockers, if you would like, here's the warm-up, I would say go ahead and pause for realsies this time. Try it on your own, and we're about to work it out and show you how to do it.
Oh, they didn't do it for real?
Oh, no.
Well, yesterday, I put some problems up on the board to practice, and I said, okay, y'all pause right here, and we're gonna wait, we're gonna let them practice on their own. What I meant to say is, you might wanna fast forward through us waiting, like me watching them work, instead I said pause. So, they would have just paused, and then the minute they started it again, it would have been me standing here watching them do their practice problems, so it was me being silly yesterday.
And then Shannon was reading her calculator in German.
Yeah. Her calculator was evidently set in German, and she couldn't figure out why she didn't recognize the buttons.
Were they really? Or is
It was,
Yeah.
yeah, it was in German. You can change the language on your calculator.
Because we didn't know what it was until after before we
I
looked
guess
at
that's
it.
what you're
I looked
doing.
at it and went, oh, look, it's in German.
Did you do that or is it?
No, somebody, these are old calculators, so somebody a year or two ago probably changed it and never changed it back. All right, warm up, here we go. One straight antiderivative, one derivative, just to keep you fresh. I gave two similar problems to the Green Sea kids. I will say this is very, very straightforward. You shouldn't have a problem with that. This one, again, derivative, you'll do fine on. Your free response answer you'd be cool with. It's turning it into a multiple choice answer, cleaned up. That's gonna be the irritating part. All right, here we go. Antiderivative from 0 to 1, blah, blah, blah. X cubed.
1/4 x to the 4th.
Okay. Square root of x.
Negative. Oh wait, we can't do that.
What should we do first to this one? Before we take the antiderivative of this piece, I'd rewrite it.
Yeah, rewrite it to 1/2.
Yeah, I'd rewrite that as x to the 1/2 and then play the polynomial game. Okay?
So 3, oh no, sorry, 2/3 x to the,
When you raise the power 1, you'll get x to the 3/2, then multiply by the reciprocal and get 2/3, or divide, which is the same thing. All right, last piece.
let's see.
Careful, it's not tangent,
It's
it's arc
arc
tangent.
tangent.
There's a huge difference. One thing I will point out about
That's
this,
not our tangent.
okay, the way y'all did it, you wrote minus, sorry, I just said it and did it, all right, minus the arc tangent. However, -1 over this is the cotangent, so you could have said plus the cotangent. I never do cotangents. I don't know that I've ever actually done a cotangent in my life. I always do tangent and just flip it. So most of you, I'm thinking all of you probably would have thought that's a tangent. So
And then just
that's fine, okay. Now we evaluated at 1, at 0, subtract. Pretty straightforward. That's gonna be a 1/4. That's gonna be 2/3. Arc tangent of 1.
X.
I'm sorry, what?
X.
I'm
Of 1.
plugging
Oh,
1 in for x. Arc tangent of 1.
I don't know what I was thinking.
Whose angle has a tangent of 1?
Whose angle?
Let's
Code.
say there's 4, is it 4?
Yeah, and again, I don't really do tangents, I do sine and cosine, which if sine divided by cosine is 1, where are sine and cosine the
So
same?
45
And I would get in the habit of
well,
radians, okay, not just degrees, because degrees don't make sense with this. All right, minus, plug in 0. That's 0, that's 0, that's 0. All right, that was easy. Okay, that's irrelevant. Doesn't always happen, by the way, be careful that when you stick in 0, you're not always going to get a 0 out. Alright, common denominator here is gonna be 12.
When the only time you don't have a 0, when you plug in 0, if there's no x in that part of it?
No, trig,
Oh, that's true.
because the cosine of 0 is not 0. Exponentials, like 2 to the 0 is not 0. So there are some functions when you plug in 0, you don't get 0 out. Okay, that's gonna be a 3. That's gonna be an 8. And this is gonna be 3 pi, for a grand total of 11 minus 3 pi over 12. That is a teeny tiny number. Because that right there is probably close to 11.
Yeah, it's like 10.
Yeah, almost 10-ish,
Almost
something like that.
11%, and that-
Okay, yeah, so that's gonna be tiny divided by, that's a tiny fraction, whatever it is. Don't know what that function looks like, but we've just found the area, and my guess is we got a bunch of area, like some stuff above and some stuff
Yeah, a lot,
below
yeah,
that's
lot.
canceling out here. It is a small interval as well, from 0 to 1 is a tiny window, so it stands to reason our area should not be that big, whatever it is. If this is, by the way, if it's calculator, I wouldn't have done any of this. I would have hit math 8 on my calculator, beep, beep, boop, done.
It's really easy.
Y'all do remember, I know you two weren't here yesterday, but y'all remember how to find the derivative. On the calculator, you go to math 8, and it sets up this little thing.
Can you fix them all?
I'm sorry, not that, that's the new thing. That's math 9,
What is
Math
that?
nine.
okay, math 9, yeah. That's math
Same
8.
Did you fix the calculator?
I have 3 of them that are fully upgraded,
Upgrade.
yeah, and I can do the others in a little while. All right, let's practice our derivative.
Okay, boss.
What are you thinking on this second one?
That's a good old quotient rule.
Good, let's think quotient.
Low,
Low,
E high,
D high.
so that's 1 over x squared, no, 1 over, so 1 over x.
Kind of. Derivative of the natural log of something is 1 over something. And in this case, we have to chain it because that's something. So it's gonna be times
2x.
2x, so it'll be 2 over x.
2 over x, sorry.
Okay. Let's see, less high, D low.
Let's see, 1/2 over, blah, 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 blah. I'm sorry.
That's okay. Treat this as x to the 1/2. Bring the 1/2 in front, lower the power 1, so 1/2 minus 1 is gonna be negative 1/2 there. I think y'all have been doing, it's only been a week and a half, but I think y'all have been doing this so long that you're starting to lose touch with your derivatives. This is why I'm trying to hit you every single day, making your brain go back and forth quickly, a lot. All over the bottom squared, which is x.
Good old x.
Now, free response, great answer. I'm done. Okay? Multiple guess, however, they would clean that up a good deal, and I gotta say, when we did this one at Green Sea, there's a point that it gets to where you're like, okay, this is good enough. You could go further if you needed to do some other stuff with it, so let's just get to the good enough spot, and if you feel like barreling through it, we can do that. Alright, I noticed that this guy right here cleans up into 2 over x,
Yeah.
okay? So I'm gonna write 2 root of x over x.
Okay.
We could take this root of x and combine them together in some way, let's not just yet, okay? Second piece. Both of these little guys are on the bottom, so it's gonna be natural log of x squared over 2 root of x, and all that's gonna be over x. probably not good enough because we've got a fraction on top of a fraction. So I'm thinking common denominator here. This guy's missing 2. And this guy's missing, if we give him a root of x, he'll become an x and we'll match up with this right here. Not the best, I guess. Good enough. So we're gonna have 4 root of x minus natural log of x squared times the root of x all over 2x all over x. Okay, this is an easy fix to x over 1. We're going to have 4 root of x minus natural log of x squared root of x all over 2x squared. I would say this is probably the point that on a multiple choice, that might be how it looks. Because I'm feeling sadistic, we'll go a step or 2 further than this, and I think it's good practice with your arithmetic. Okay, first thing I notice, 2 things actually. Number 1, you got a couple of roots of x's here that they might have factored out, and number 2, they could have done a log thing. This power here could have been brought out front. So to baby step this, we could have had a 4 root of x minus 2 natural log of x root of x
Yeah,
over 2x squared.
take out a root.
Then they could have taken out a 2 and a root of x and left behind a 2 minus natural log of x all over 2x squared. And then I think last but not least they would have canceled the 2's. So you would have gotten root of x times 2 minus natural log of x all over
X squared.
x squared. That is probably the cleanest. Again, you can do something with these, but it doesn't really help the situation or give you any new information. This right here is about the cleanest you can get to give you all the information you could ever want. It is factored, so if I have to set it equal to 0, it's real easy to solve this, okay? I think that's pretty good. Free response, 100% right. Done, yay. Multiple choice, maybe here, maybe there. But notice how much calculus is involved.
1.
One line, beautiful quotient rules,
Free
and
response.
algebra. Good stuff. All right, any questions from homework or from yesterday's? Thing. Yep.
Shannon's out of here. So,
Yeah, no homework questions, because Shannon's not here. Class gets quiet when you're not here, nobody has homework questions when Shannon's not here. Notes aren't taken when Chelsea's not here.
well, they are.
I don't know, the kids are like, ugh, Shannon must have done this. Ugh. She did put the dates on the top of it like you do, just to be nice. She tried to write kind of big. There we go.
That was a quiet class.
We got a lot of work done yesterday, I'd like to think. It wasn't a taxing lesson, so pretty good. Today is a monster lesson.
Good. I'll be here tomorrow till 1. I'm going tomorrow.
Good. Shannon's gonna have a world of hurt to come back to.
Then she thinks she's gonna beat me, and then she doesn't come to this class.
Probably one of the most important lessons of this whole unit, yeah. Oh well. Oh well. Okay, if there are no questions, we'll go ahead and jump in with the fundamental theorem of calculus, part 2. How adorable.
I know, it's so cute. It's 75 fluid ounces. Yeah, it's from shit. It's so cute.
Adorable.
A mini can.
Adorable.
It's 100 calories.
Okay, I'm gonna need to use the graph here a good bit. And I'm going to try and make sure they can see the graph. Now, I don't know how sturdy this thing is. We're gonna find out if it,
They can see it.
all of it, or just
Yeah, because you can see the.
enough. I don't grab it, it's mainly right here. Can I see
Yeah.
this?
Yeah, you can easily see
Okay.
that. You want to move it more to this, the left side?
That way?
Yeah, because it's, I don't know, it might be up to, it doesn't matter actually.
I'd like to do a little, like, writing and scratch work here, and then a picture here. Can y'all see it okay? Everybody good? All right, fundamental theorem of calculus, part 2. And I'll move this out of the way in a second, but it's good for picture's sake right now.
What's the first one?
Fundamental theorem, part 1 was the antiderivative yesterday. The antiderivative just means, or when you see the integral, take an antiderivative,
Okay.
evaluate the 2 points and subtract,
Hmm.
right? Here. Okay, could you people graph this?
Yeah.
Could you graph that? How hard would that be on a scale of 1 to pi? How hard would that be?
Negative pi.
Graph it for me. How would you graph that?
Have your slope
Mm-hmm.
and a y-intercept. So you can just go 2 y-intercept, a dot, and then go from your slope. Assuming that x is, the t is the.
All right, yeah. Call this the independent axis and this the dependent axis, okay. Remember ruler.
I'll ask Mr. Parker if he has a rule.
No, for the sake of this, I can freehand it, and I apologize if it's not perfect. It's already off. That's hideous. So out of practice. Alright, it looks wavy, but it's not. Okay, note to self, get a ruler.
You gonna watch this with YouTube?
No. Okay, ta-da! Okay, what does this mean to you? What do you think that would mean?
You can do, it's saying from any of the area from 0 to whatever.
Okay, good, yeah, it's an area question. It's asking you area. They want you to start at 0 and then go till wherever I tell you to stop, okay? Of that.
Yeah.
Got it, all right.
Like x equals.
We're gonna call this a function,
That's a function.
okay? This is a function. All right? So we're gonna name this function, which interpreted a couple different ways. It's a function that changes based on what x is, but it also means how much area I have gained up to that point.
So we're taking a derivative of the area again.
We haven't taken a derivative of anything yet.
Well, I mean, like, we're trying to find the
We
rate.
will eventually, not yet, but we
Yeah.
will do that. Okay. Let's see if this makes sense to you. What is a of 0?
0. Oh, yeah.
Okay. Tell me how you came to that conclusion so quickly and easily and what it means to you.
Well, because 0, 0, that means it's, if you were trying to find the area, it's just a flat line, so there's no actual area.
Okay. If we were to put it into the formula, it would look like this. Graphically speaking, You're telling me you want me to start calculating area at 0, and you want me to stop calculating area at 0, so how much area have I accrued?
0.
None. Alright, that's a nice little property to know. If you start and stop at the same place, you don't get any area. That's kind of obvious, alright?
Kind of.
Kind of obvious, yeah. Alright. What is A of 1? There are two ways to do this, by the way, and I heard you say something which is leading towards one way. Okay? Alright, go.
1/2 t squared plus 2t.
Okay, that is us taking the antiderivative, and then we're gonna evaluate this from 0 to 1. Alright, what happens when we stick in 1?
1/2 plus 2
Minus
minus 0.
0, alright. You do need to check and make sure that it is indeed 0. Alright, for a grand total of
3 halves.
3 halves, 1 1/2, oh, wait,
Oh wait, no, 5 twos.
yeah, 5 twos. Alright, that is one way to do it. Can you think of another way to do this one? This same problem?
We could really just do, because it's a straight line, we could do like trapezoids or something.
But we don't need to be fancy about it at all. You told me that this function from the very beginning was accruing area. Start at 0 and go out to x, and it represents how much area we have gained up to that point, okay? So this function, when you think about it, is gaining area. Okay, why don't we then? You want me to start at 0 and end at 1 and gain area. Fine.
That's an easy thing.
How much area have I gained?
1.5, 2.5.
Yeah, 1 block, 2 block, half block, 2.5. Now, it works nicely, like you said, because this one has a linear side to it. If it were curved, we'd probably need to rely more on that, but the option is there, okay? A of 4. Whichever way you want to do this, antiderivative, area, knock yourself out. This would be the calculus, well,
16.
yeah, I think that's right. This would be the,
I'm just counting squares like kindergarten.
this would be the calculus way to set it up. We could take an antiderivative, which we've already done. There's no sense in reinventing the wheel there. 0 to 4. 4 squared root of 16 is 8, plus 8 minus 0, so yeah, 16. That's way number 1 with calculus. 4. We can come over here, start at 0, end at 4, and add, all of it together, all the green. We do that. If you're counting squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Yeah.
Okay, is that what y'all did?
Yeah.
I did
15, 16. Or you could do the area of a trapezoid. You could do base 1 is 6, base 2 is 2, huh? Yeah, good. Height would be 4. You could set up a trapezoid if you want to
4
do that.
times 2, no, 4
Or you could do a 4x4 triangle and then a block of 8 at the bottom. Whatevs, okay?
It's a linear line, you can do a bunch of things.
Yeah, you got choices there. Okay, well, all right, that doesn't seem too terribly rough, that the we'll call a function, it is changing and it has different values based on how far you have gained area. All right, let's spice it up a little bit. A of -2. Take 30 seconds and come up with an answer. Do that real quick, using whichever technique you would like to do.
-2.
30 seconds. And come up with whatever area you think you got. All right,
2.
2. -2. I hear a 2 and I hear -2.
I'm just looking for it.
What do you think, Chelsea? 2. What do you think, Ray? 2. What about 2? 2, 2, 2.
She's somehow gonna be right, or else when we showed up.
Let's go to number
You still say -2? All right. Which way would you like to do this one?
I like counting. We can't do it right
All right, counting. I got
now. 1.
1 block, 2 blocks, 2. All right. Do you want to change your vote now?
No, I'm just saying, I know that makes sense, but I'm just thinking about it and now.
Oh, you did the math. Okay. Let's do the math. Start at 0, go to
I think
-2.
we already have the integer. It's just nice.
We do, yeah. All right, let's stick in -2. -2 squared is 4, half of that is 2. 2 times -2 is -4. Stick in 0, we get 0 for a grand total of,
Don't you do it the other way around?
I'm doing it in the order that the fundamental theorem part 1 tells me to do, top minus bottom,
Negative.
-2. What? So who's right? Did the math lead us astray? And all of you were correct?
Yeah. Math led us completely astray.
No,
What?
did not. Here's why. From our starting line, from our starting point, moving to the right means we are gaining area. Okay?
So you're
Moving
getting
to the
here
left.
side.
Moving to the left would mean that we are losing area. Okay?
Awesome.
So this back here, the part you just found, would technically be lost area.
So,
Because our starting point was 0.
question.
Yes. Ooh, go ahead.
This is negative area. Well, if this is our starting point, this is negative area. This is negative area. So
Correct.
what's this?
Positive area.
Ooh.
Okay.
Oh god, that's
Yeah,
scary.
that was my next question. Okay. I got room, right? Put a big star up here. I'm gonna erase a whole bunch of stuff, but what about this one then?
Okay, let's do this. 4. It's 0.
It is 0. Do you know why?
Because it's the two canceled, but.
Yeah.
I mean,
You could do the arithmetic, and the arithmetic will tell you the answer is
Negative.
0.
Zero.
Okay? Or you can look at this. From our starting point, area to the right is being gained. So, for instance, this would have been gaining positive area, this would have been gaining negative area, which is technically negative. Left, we're losing, so we have lost positive area, which is negative. But once we cross over here, we are losing
Negative area.
negative area, which technically means we are gaining area. Okay?
Yeah.
And I give this little chunk and that little chunk are the same size, so yes, it should be 0. You didn't have to do the math, but if you crank through it, you will get an answer of 0 for that one. Okay? Now, how is the game going to change? May I? Very good. How is the game going to change if I do this?
You can't change the game
I
changes
can.
you.
Does that change anything at all?
Yes, completely changes
Really?
it. Yeah.
All right. What would a of 0 be? What was a of 0 last time?
0.
0, all right.
Now 2,
2, why?
because we're starting at -2. I mean, we're starting at -2 and going to -2 to 0.
Starting at -2, we're gonna use this now as our starting point. So if I go from here to there, which is in a right direction, we're gaining that area, so this answer would technically be 2. Do you understand that? That it changes, it's the same idea, just depending on the starting point would determine how much area we're gaining or losing from that reference point.
So your A is always your reference point.
Your
Big A
That's your
point.
number on the bottom,
Yeah.
whatever.
Yeah.
Yeah, the little a, not big A, but
Not
little
big,
a.
Little A is always
Right,
your.
is always our starting point. And then we're gonna let it go until we decide to stop gaining area. Okay?
Losing area.
Or losing area, yeah. All right, what would a of 3 be for this one?
And 3.
I know the, you can do the math, by the way. I think this is bothering some people.
Negative area
Yeah, we
there. So
don't,
there's no such thing as negative area now.
in this problem,
In
there
this
wouldn't be, right? If we start at -2.
If we start -2, there's no such thing.
Because all this stuff that would be going left, we'd be losing negative area. So yeah, there would be no negative area in this problem. But what is 3? A of 3.
3, so.
Alright, so that's a 5 on the bottom
Average of 1.
and a 5 on top. So I'm doing a triangle.
Oh, so yeah, 25, half 25.
Can I go up halves? 12 and a half, whatever. Okay. 25.
25 tooths.
25. A of -2.
-2
Stop
would
it
be
at
0.
0.
That took a little too long. That should be 0. Thanks. Done. Got it.
3 points.
A of -3.
Half.
Yeah.
You're technically losing the negative area, so it will be positive, and it's only a little half a sliver square there, so positive 1/2. Okay.
Somehow we did the concept of losing negative area that didn't exist in the first place, but I'm guessing in the whole scheme of things it does exist. Like when you have a box and it's all positive area, losing negative area doesn't really make sense to me.
You've been told for years and years that there does no, negative area doesn't make sense. You take the area of something, you have the area, that's it, it's area. Not entirely true, all right? Negative area does exist.
What is negative area in real life?
In conceptual terms, imagine that